Akamai Technologies is the leading provider of cloud services for delivering, optimizing, and securing online content. The Akamai Foundation helped fund and send a team of 4 female mathematicians of school age to the European Girls Mathematical Olympiad. And we are deeply grateful to the Akamai Foundation for its very generous support of the Advantage Testing Foundation Math Prize for Girls. Our next speaker, Kate Jenkins, is Principal Mapping Architect at Akamai Technologies. She helps design the software algorithms that determine the flow of traffic on Akamai's worldwide network. Her group's software directs about 1/4 of the world's web traffic every day. Math has always been an important part of Kate's life. She competed nationally in MathCount's math competitions, took advanced math classes, and majored in mathematics at Stanford University. After Stanford, Kate worked as a computer game programmer at Looking Glass Technologies here in Cambridge, Massachusetts. She then went to Cornell University in pursuit of a PhD in applied math, and left with a master's degree in computer science, an abiding interest in graph algorithms, and a dream job at Akamai. Kate enjoys sharing her passion for math and computer science with others. She was a driving influence behind Akamai's Girls Who Code Summer Immersion program, bringing high school girls to Akamai for 7 weeks this past summer. She ran a How the Internet Works workshop at the Girl Scouts Expo, STEM Expo in Framingham in March, and for Chick Tech in San Francisco. She also supports the Cambridge-based Girls Angle Math Club, giving talks and writing articles on algorithms. Please welcome another member of the math tribe, Kate Jenkins.
Good afternoon, and thank you for the introduction. I'm honored to have the opportunity to speak to you today on behalf of Akamai and the Akamai Foundation. I'm also very proud to work for a company that supports the Math Prize for Girls and girls' excellence in mathematics. I apologize for reading from my notes. There's a lot I want to tell you, and I want to make sure I get it right. And my strength is math and computer science, and not public speaking in front of hundreds of people. In the next few minutes, I'll talk about the role of math at Akamai and in my own work. And I'll tell you a bit about my own journey, how I ended up where I am today, and some lessons that I've learned along the way. As some of you may already know, Akamai was founded 17 years ago by MIT applied math professor Tom Layton and his grad student, Danny Lewin. They observed that the internet would be faster and scaled better if people could fetch web content from a nearby computer that already had the data that they needed, instead of having to go to an origin server that could be very far away. They hatched the idea of building a global network of servers to store content near end users, and developed caching algorithms to determine which data to store on which computers. The Akamai mapping system is at the heart of Akamai, constantly measuring internet performance and deciding who to send where to get the content they need quickly. Mathematical principles are at the heart of mapping. We use mathematical modeling, optimization algorithms, measurements, and statistical analysis to operate our network and ensure that it runs smoothly. Mapping is a massive optimization problem involving millions of decisions that need to be made very quickly. And if we get it wrong, we can melt the internet. So no pressure. Today, Akamai has over 100,000 servers in over 90 countries. Between 1/4 to 1/3 of the world's web traffic is served from our servers every day. If you do anything online, if you use social media, watch movies, shop, read the news, download software, you probably are using Akamai every day without realizing it. I've worked on the Akamai mapping system for 14 years now. First as the software engineer responsible for our global load balancing system. It's the code that takes all of the internet load and performance data that we've gathered as input and decides who should be sent to which Akamai data center. I am now mapping architect. making sure that all of the different parts of Akamai's mapping system work well together and continue to meet our needs as the internet constantly evolves and changes. My math background helps me every day. The structured, logical, precise way of thinking, the ability to hold a complicated idea in my mind and probe it for errors or weaknesses, the ability to sift through the noise and see what is essential to a problem. All of these skills were honed by my training in math. 25 years ago, I had no idea that I would be where I am today. I was probably much like many of you. I liked math and excelled at it. I participated in math competitions at the national level. Like perhaps some of you, I didn't know what I wanted to do with my life. I liked finding the right answers to problems, and I liked winning, perhaps more than was good for me. I wanted to be successful and pick the best career path for me, but it was unclear what that meant. There were so many possibilities, and I didn't know what really mattered to me. I have learned that that's okay, that you discover what is important to you in life by living it, and being willing to try something new based on what you've learned. I've learned that you need to trust yourself and choose what is right for you. And a good way to discern this is to ask yourself Sheryl Sandberg's question: what would I do if I wasn't afraid? And then do it, even if you are afraid. The support of other math women is invaluable, and a strong foundation in math will serve you well, whatever path you choose. My own story goes something like this. I took part in a very demanding university-level advanced math program in high school. I did well, but sometimes got overwhelmed. And a big reason I stuck with it is because the only other girl in the program became my best friend. And this was our only chance to see each other. And we wouldn't let each other quit. And we are still best friends today. She and I both went to Stanford for undergrad. I studied math because I liked it and to keep my options open. While there, I discovered that I liked computer programming and how computer graphics use linear algebra and logic to create beautiful art. I learned that I wanted to use my math brain to build and create things. I learned that it is okay to choose not to go to math grad school and become a math professor, no matter how much pressure you feel to do so, because there are so few women who do. It is more important to live your own life imperfectly than to live someone else's perfectly. And it's okay to disappoint people if it means being true to yourself. I landed a job at computer game company Looking Glass Technologies, based on my strong math background and somewhat dubious coding skills. I learned a ton. It was really fun, interesting, and challenging. I loved working together with smart, passionate people to build cool technology. But I wanted that technology to matter, and I realized that ultimately computer games didn't cut it for me. So I left for applied math grad school at Cornell University, where I finally discovered graph algorithms and how my favorite kinds of math, linear algebra, combinatorics, probability, can be used to create efficient algorithms that solve real-world problems and to prove that they work. And there I learned about Akamai. So here I am. My work impacts millions of people every day. I use my math brain. I have brilliant coworkers. I have also rediscovered how awesome it is to have math women as colleagues and friends. Some of you have met Liz Borowski, the director of mapping at Akamai. I believe she spoke here last year. Her support gave me the confidence to step into my role as architect at Akamai. Working with other Akamai women on outreach programs like Girls Who Code and the Girl Scouts is tremendously satisfying for me. I had no idea that I would end up at Akamai when I was your age. How could I? The World Wide Web didn't even exist then, and I didn't know what I wanted. But I ended up here today in front of all of you with a career that I love and is right for me. And what a place to be. Looking up from my notes and out of you, I see 300 of the most talented math girls in the country, all together in one room, listening to me still talking. Each of you is so much more than your test results and your accomplishments, even though they're very impressive. The potential in this room is staggering. Embrace your own unique journey. Work hard. Be true to yourself. Act fearlessly. Support each other. And you will change the world in ways you cannot begin to imagine. Thank you very much.